Hello, this is FASTECH. Today, I will explain the key terms when talking about FASTECH's easy servo, position accuracy, lost motion, and overshoot. There are three main terms to explain. The terms are position accuracy, lost motion, and overshoot. If you grasp these terms, you can easily understand what advantages each servo has and which applications it should be applied to. First, let me explain the term position accuracy. Position accuracy is the maximum difference between the command position value and the actual position value of each positioning point by sequentially moving the motor at a certain interval in one direction from the reference point. To put it simply, it is the maximum difference between the commanded position value and the actual position value when the motor is operated in one direction. The important point is that the rotation direction of the motor must not be changed. For example, please look at the graph here. The horizontal axis refers to the measuring point. And for the vertical axis, the pink graph refers to the commanded position value, and the blue graph refers to the actual position value. Please look at the 11th measuring point. The commanded position value is 50, but the actual position value is approximately 40. The position accuracy can be calculated by subtracting the actual position value from the commanded position value. So, the position accuracy is 50 minus 40, that is 10. I'll explain the error that occurs when the rotation direction of the motor changes in the next part, lost motion. With a demonstration, I'll show you what position accuracy is. First, let me explain the specifications of the demonstration and measurement conditions. As you can see, there is a demonstration in which you can visually observe the movement of the motor shaft by attaching a mirror to the motor shaft and reflecting the laser point on the screen. The distance between the demo jig and the wall is 8.4 meters. With the demonstration I explained, let's compare whether the actual position comes the same when the motors move 0.36 degrees in one direction. As you can see, if the position accuracy is good, you can see that the intervals are all constant and there is no position error. If the position accuracy is poor, the intervals are not constant and you can see position errors. Good position accuracy means that when it is moved in one direction, it moves accurately without showing any errors. The following is an explanation of lost motion. Lost motion is measured as follows. First, move the motor sequentially at a certain interval in clockwise direction from the reference point. After that, measure the actual position value at each measuring point. Then, reverse the direction to counterclockwise and measure the actual position value in the same way, and then return to the reference point. The maximum difference between the actual position values of each positioning point, measured in both directions, is called lost motion. The important point here is that the direction must be changed to measure the lost motion. To explain easily, you can think of it as the maximum difference between the actual position value when the motor is commanded to move at a certain interval in the clockwise direction and the actual position value when the motor is commanded to move at a certain interval in counterclockwise direction. In other words, lost motion refers to the position error that occurs when changing direction. For example, please look at the graph. The horizontal axis of the graph is the measuring point, and the vertical axis is the actual position value. The blue graph shows the actual position value when commanded to move clockwise, and the pink color represents the actual position value when commanded to move counterclockwise. Now, please look at the 15th measuring point. For the clockwise movement, the actual position is 0.1. And for the counterclockwise movement, the actual position is negative 11. The lost motion is calculated by subtracting the counterclockwise actual position from clockwise actual position, which is 0.1 minus negative 11. That is 11.1. I'll show you a demonstration video with the same demonstration you just saw. The difference from position accuracy we saw earlier is that the motor rotates alternately in clockwise and counterclockwise directions by 360 degrees. That is, in the case of lost motion, direction has to be changed. If there is no lost motion, the motor returns to the target position without position error regardless of the direction. But if there is lost motion, the motor stops at different position depending on the rotation direction, resulting in position error. In other words, lost motion refers to the position error that occurs when the direction changes. Finally, I'll explain what the overshoot means. Overshoot is a value indicating how far the motor has exceeded the target position after it reaches the target position. Please look at the graph. The horizontal axis refers to the time, and the vertical axis refers to the position, and this is the target position. In general, the motor does not reach the target position at once. The motor goes through a process that exceeds or falls below the target position, as shown in the red line. At this time, the value indicating how far this target position has been exceeded is called overshoot. And overshoot is related to settling time, which is the time it takes to achieve and maintain the target position based on command position value given by the system. In simple terms, the settling time is the time it takes for the motor to reach its target position. In other words, the larger the overshoot, the longer the settling time. I'll show you the overshoot with a demonstration which has the same structure as the demonstration you saw earlier. The motors will move 90 degrees at 2400 RPM speed with 50 milliseconds of the acceleration and deceleration time. Now, let's see how the overshoot differs when two motors are moved under the same conditions. The motor on the left stops at the target position without the overshoot, but the motor on the right returns to the target position after exceeding the target position, showing the large overshoot. As you can see, the overshoot is the value of how far the motor has exceeded the target position.